Hi, if you built anything with SQS or Lambda, you've almost certainly hit this at some point. A message fails to process, your Lambda throws an error, SQS retries it once, twice, 3 times, and then silence. The message is gone, no alert, no log entry you'd actually notice. The data just disappears and your system looks completely healthy. This is one of the most common failure modes in serverless architectures, and it's dangerous precisely because it's so quiet. In this video, I want to give you a solid mental model for dead letter queues, and what they actually are, how they work across SQS and EventBridge, and how you build systems that handle failures deliberately instead of silently. And we're going to start with the simulation, because I think seeing it in action is worth more than any definition I could give you. Let me show you exactly what happens to a message when things go wrong. So here's the baseline, the happy path. A producer publishes a message to an SQS queue, a consumer picks it up, does some processing, and writes the result to a database. Message comes in, data is saved, everything is clean. This is what we're designing for actually, but it's not what always happens. Let's see the failure scenario. Now let's say some of those database writes start failing, maybe there's a transient network issue, maybe the payload is malformed, maybe a downstream service is timing out or something. SQS will retry the message automatically, but there's a limit. Once it hits the maximum receive count, the default behavior is to discard the message. Watch what happens here. The message just vanishes, no error is displayed to you, no alert. The queue looks empty and healthy, but the data that your system promised to process, it's gone. This is the problem a dead letter queue solves. So let's take a look at the next scenario. The scenario is the same, but now we have introduced dead letter queue on our source queue. And when the message exceeds the retry limit, instead of being silently dropped, it gets routed here to the dead letter queue. And this changes everything, because now the failure is visible, it's inspectable, and critically it's recoverable. A dead letter queue isn't really error handling, it's failure isolation, and you're not trying harder on a bad message, you're moving it out of the way so that system keeps running. And once you notice that that letter queue is filled up with messages, you deliberately figure out what the failure was on your own terms. And that is the mental model, and everything else in this video builds around it. So let's go deeper. In AWS, dead letter queues work in different services in SQS, SNS, and EventBridge. Let's start with SQS scenarios first. In successful scenario, producer publishes a message to SQS queue. Then some consumer, for example, Lambda function processes it. And if the processing was successful, Lambda function then in the end deletes this message so that it is no longer available in the queue. But what happens if processing fails? When you create an SQS queue, you specify maximum receive count. And this value defines how many times the message becomes visible in the queue before it is transferred to a dead letter queue. So in our scenario here, producer publishes a message, Lambda processes that message, and on every failure, receive count increments, and when the maximum receive count is achieved, then the message is delivered to a dead letter queue, and it is available there for our further observation. Okay, so now you understand the SQS mechanics. Message fails, retry is exhaust, and the message lands in the dead letter queue. But SQS isn't the only place messages can die. The same problem where the fail message go exists in SNS and EventBridge. And there is slightly different in each case, so let's walk through both. First, as a refresher, SNS is a fan-out service. You publish one message to one topic, and SNS delivers it to every subscriber, Lambda functions, SQS queues, HTTP endpoints, email, whatever subscriber types there are. Each of those deliveries is independent. SNS doesn't care what your subscriber does with the message, it tries and it moves on. Now, what happens if one of those deliveries fail? Say your Lambda subscriber throws an unhandled error, or an HTTP endpoint returns a 500. SNS will retry. It has a built-in retry policy. It'll back off and try again over a period of time. And these retry timeouts and the number of retry attempts, they are different per subscriber type. And eventually, if the delivery keeps failing, the SNS topic will give up and will not deliver the message, and by default the message will silently be dropped. This is the key to understand about SNS dead letter queues. It's where people often get confused. The dead letter queue is configured on the subscription, not on the topic. This means that each subscriber can have its own dead letter queue or none at all. If you have 5 subscribers and only configure a dead letter queue on 2 of them, and the other 3 will still drop messages silently when they fail. So the practical rule is every SNS subscription that matters should have a dead letter queue, not every topic, every subscription. The dead letter queue itself is just a standard SQS queue, same queue that you have already seen. So everything you know about inspecting and replaying messages from SQS applies here too. EventBridge works differently to both SQS and SNS. Instead of queues or topics, we have an event bus. Publishers put events on the bus, rules evaluate those events, pattern matching on events structure, and route those matching events to targets. A target can be Lambda function, step function, state machine, SQS queue. On API destination, there is a lot of options. Now what happens when EventBridge tries to invoke a target and fails? EventBridge has its own retry policy. By default, it retries up to 24 hours with exponential backoff. But once those retries are exhausted, same story. The event is gone, unless you have configured a dead letter queue. In EventBridge, the dead letter queue is configured on the rule target, so per target, not per bus, not per rule. One rule can have multiple targets. Each target can have its own dead letter queue, or none at all. Same pattern as in SNS subscriptions. So let me summarize where we configure the dead letter queue in each service, because this is important. With SQS, the dead letter queue is configured on the source queue. With SNS, the dead letter queue is configured on the subscription, not the topic. With EventBridge, the dead letter queue is configured on the rule target. 3 services, 3 different places. The concept is the same. Isolate failures, but where you attach that safety net is different in each case. That's the thing worth remembering. Okay, now that you know how dead letter queues work across SQS, SNS, and EventBridge, I want to give you 7 rules you can act on immediately. These are not theory, they are the things that will actually save you time in debugging and troubleshooting systems. So the rule number 1, every queue that matters should have a dead letter queue, no exceptions. If your queue is processing messages your business needs and your business depends on it, it needs a dead letter queue. Doesn't matter how simple the consumer looks, doesn't matter how unlikely failure seems. The cost of adding dead letter queues near zero. The cost of not having one when something breaks, that is higher, so no exceptions. Rule number 2, dead letter queue must have the same type as the source. FIFO to FIFO, standard to standard. Short one. AWS enforces this. It's less best practice and more a rule that you are forced to configure in a special way. Mixing types throws a config error when you try to deploy the dead letter queue. Next rule. Alarm on dead letter queues depth more than 0, always. A dead letter queue with no alarm is just a place where messages go die quietly. You have added infrastructure but no observability. The rule is simple. Any message in a dead letter queue is a broken promise your system made. Next rule, never replay blindly. Inspect first. Classify the failure. This is the one people skip when they are in a hurry, and it's the one that burns them. Before you replay anything from dead letter queue, you need to answer 2 questions. Why did this message fail, and is replaying it safe? Some messages are malformed, some expose a logic bug. And if you replay a poison pill without fixing the root cause, it will fail again and you are back where you have started. Except now you have wasted the retry budget as well. Inspect the message, check the receive count, the approximate first receive timestamp, any attributes you have attached classified before you touch the replay trigger. Next rule, exponential backoff plus jitter for transient failures. When you do replay, don't hammer the queue. If the downstream was unavailable 10 minutes ago, blasting it with every failed message simultaneously is a great way to take it down again. Exponential backoff means each retry waits progressively longer, 1 second, 2, 4, 8, 15, 32, etc. Jitter means you add a small random offset to each delay, so retries spread out across time instead of spiking together. Next rule, route persistent failures to a human ops queue, not back into the loop. Some messages will never process successfully no matter how many times you retry them. If you keep replaying them, you've built an infinite loop that wastes compute and masks the real problem. The pattern is a second dead letter queue, a human ops queue. When a message has been replayed more than maximum retry count, it goes there, it stops moving automatically, a human reviews it, makes a decision, and either fixes the data or closes the ticket. The human ops queue is where failures become visible work items, not silent data loss. Set message retention period to the maximum, up to 14 days. By default, SQS retains messages for 4 days. If you don't catch a dead letter queue filing up within 4 days, the evidence is gone. Set your dead letter queue retention period to 14 days, the maximum SQS allows. This gives you 2 full weeks to investigate, escalate, and replay before anything is lost permanently. This is a one-line config change. There's no reason not to do that. So those were the 7 rules. Most of them are a few lines of config. None of them require re-architecting things. The cost of not doing them is silent data loss, missed failures, and systems that look healthy while quietly breaking. That's the whole series. Dead letter queues, what they are, how they work across SQS, SNS, and EventBridge, and how to run them properly in production. If this was helpful, like the video, subscribe to the channel. See you next time.